So now we are going to review radical numbers, a little bit about radical numbers. So simplify each of the following. So when we take the square root of 4, the square root of 4 is going to give us a whole number. The whole number is going to be 2. It's actually going to give you plus or minus 2. So positive 2 times a positive 2 is going to give you 4, and a negative 2 times a negative 2 also gives you 4. Now this part we don't really worry about in geometry, because with geometry, for the most part, everything is positive. When you're measuring lengths, angles, they're usually all positive in geometry. So I just want you guys to worry about the 2. All right, the square root of 9, that also gives you a whole number. That gives you 3, because 3 times 3 gives you 9. The square root of 16 gives you 4. And the square root of 25 gives you 5. Okay, so you have some certain properties that we can follow. We have first the product property, which, for example, if you're taking the square root of 200, you can actually split that into 100 times 2, because 100 times 2 gives you 200. Okay, so not just that property, but to follow along with the property, you can take the square root of 100 and the square root of 2 separately. Okay, so that's just one of the rules. And then from there, since we can take the square root of 100 and get a whole number, that gives you 10, and the 2 is going to stay trapped inside the square root. So we can't take it out because you can't take the square root and get a whole number. All right, this next example, sometimes it can give you the square root of 27 and have you multiply it times the square root of 3. So you can actually just put it inside the same square root and multiply them. Okay, and this only works for multiplication and division. Okay, right now we're just worried about the multiplication. It ends up giving you the square root of 81, which is equal to 9. So here they want us to simplify the following. Okay, so before we simplify these, we need to remember our perfect squares. So your perfect squares, for example, 1 squared gives you 1, 2 squared gives you 4, 3 squared gives you 9, 4 squared gives you 16, 5 squared gives you 25, 6 squared gives you 36, 7 squared gives you 49, 8 squared gives you 64, 9 squared gives you 81, 10 squared gives you 100, 11 squared gives you 121, 12 squared gives you 144. Okay, so we need to remember our perfect squares. So for example, here we have 20. We need to break this down into 2 factors. Okay, so we have the square root of blank times blank gives you 20. We don't know what that number is. When you're picking your number, you have to pick one of these perfect squares. Okay, so starting here, in order for me to get 20, well, I know that 4 times 5 gives me 20. Okay, so then I go ahead and write it down into 2 separate square roots. We have the square root of 4 times the square root of 5. Now we can take the square root of 4 and get a whole number. That gives us 2, but we can't take the square root of 5 and get a whole number, so that is going to stay trapped inside the square root. Okay, and that's it. That would be our answer. That's how you would simplify a radical. So moving on to the next one, we have 63. We go through these numbers, so we check to see which one of these will divide into 63. So we have 1, 4, 9, 16, 25, 49. And that's already too big of a number. So the only number that divides into 63 would be 9. Actually, 9 times 7 gives you 63. Okay, we can take the square root of 9 and get a whole number. So I'm going to go ahead and break it down, the square root of 9 and the square root of 7. When we take the square root of 9, it gives us 3, and the 7 stays trapped in the square root. All right, next we have 80. So on here we have 1, 4, 9, 16, 25, 36, 49. The one that is going to divide, we actually have 2 numbers. We have 4 and we have 16. You need to pick the greatest common factor. So your greatest one is going to be the 16. Okay, I'm going to show you why you can't pick the 4. Well, you can pick the 4, but it's going to be way more work. So 4 times 20 actually gives you 80, right? So when we take the square root of 4, we get 2 and the square root of 20. But 20 can also be broken down, so it can also be broken down into 4 times 5, which results in you guys doing more work or you guys making a mistake and leaving it like this 2 in the square root of 20, and this would be considered wrong. Okay, so always go with the biggest number. So let me go ahead and redo this. So I said 16 times 5. gives you 80. Okay, then we break it down into two different square roots. We have the square root of 16 times the square root of 5. Well, the square root of 16 gives us 4. And 5, we can't take the square root of 5 and get a whole number, so it's going to stay trapped inside the square root. All right. The next one here, we have the square root of 3 times the square root of 12. Let's go ahead and put them in the same square root, so 3 times 12. Well, we know 3 times 12 gives us 36, and the square root of 36 is 6. And that's it. All right, the next one we have 6 times 24. Okay, so I'm going to go ahead and multiply 6 times 24 in the same square root. Now 6 times 24 is going to give me 144. And we can take the square root of 144 and get a whole number. That gives us 12. Okay, this next one is the square root of 14 times the square root of 3. We're going to go ahead and put it in the same square root. So this is going to give us 42 times 3. And then this is the square root of 126. Now, if we try to take the square root of 126, we don't get a whole number. So we're going to have to see which one of these will divide into 126. So I believe 126. Okay, 9. So 9 times 14 will give you 126. So unfortunately, this one does not simplify easily like the other one, so we have to leave it in radical form. Now we can take the square root of 9 and get a whole number, but we can't take the square root of 14 and get a whole number. The square root of 9 gives you 3, and the square root of 14, that 14 is going to stay trapped in there. Okay, and that's it. Okay, the quotient property for A is greater than 0 and B is greater than 0. When you try to take the square root of A over B, you can split it into two different square roots. So for example here, you split into two different square roots, the square root of 25 over the square root of 49, which ends up being the square root of 25 is 5 and the square root of 49 is 7. Okay, you can also work this in reverse. If they're in two separate square roots, you can combine them into one square root, divide the numbers, and then take the square root of that. Okay, so for example here, we have the square root of 64 over the square root of 25. We can do it in two different square roots. The square root of 64 gives us 8. And the square root of 25 gives you 5. If you can simplify the fraction, simplify it. If you can't, leave it as is. All right, let's go ahead and look at this one. Let's go ahead and put it under the same square root. So we have the square root of 200 over 8. So let me see if we can divide 200 by 8. Yes, we can. It gives us 25. So the square root of 25 we know is 5. And then last, we have the square root of 49 over the square root of 100. So we're going to go ahead and split the square root. We're going to take the square root of 49, which is 7, and the square root of 100, which is 10. If you can simplify the fraction, go ahead and do that. If not, you can leave it like that. Okay. The last thing is rationalizing the denominator to eliminate radicals from the denominator. Okay. So here, if you're trying to rationalize, if you kind of ignore the rest of this for now, they give you something like this, and you have a square root on the bottom. Somebody made up this rule that you cannot have a square root on the bottom. You have to do what they call rationalize it. So in order for you to get rid of the square root on the bottom, what you're going to do is, if the bottom is the square root of 2, then I'm going to multiply the top and the bottom by the square root of 2. Okay. Well, the square root of 2 times the square root of 2 would give you, they kind of missed this step here, but it gives you the square root of 4. Okay, and we know the square root of 4 is 2. On the top, they went ahead and multiplied 5 times 2, which gives you 10. So let's go ahead and try to rationalize some of these problems. So here we have 4 over the square root of 5. So we're going to multiply the top and the bottom by the square root of 5. Okay, so this equals, on the top we have 4 and the square root of 5. And on the bottom, the square root of 5 times the square root of 5 gives you the square root of 25, which is just 5. And that's it. We have 4 over 5 and the square root of 5. All right, the next one here, I have a square root of 6 on the bottom, so we're going to rationalize this by multiplying the top and the bottom by the square root of 6. So on the top, we get 1 times the square root of 6, and on the bottom, we get the square root of 6 times the square root of 6, which gives you the square root of 36. We can take the square root of 36, and that gives us 6, and then this one that's here in the front, it becomes invisible, so it'll just be square root of 6. And this last one, we have 3 in the square root of 2 over the square root of 8. So we're going to rationalize it, meaning we need to get rid of the square root that's on the bottom. So we multiply the top and the bottom by the square root of 8. So here I get 3, and the square root of 2 times 8 gives you 16. Okay, you can't multiply times the 3 because the 3 doesn't have a square root. And then on the bottom, the square root of 8 times the square root of 8 gives us the square root of 64. Okay, we can simplify this more. We know the square root of 16 is 4, and the square root of 64 is 8. Well, 3 times 4 gives us 12, so we have 12 over 8, and then we can't leave our fraction like this. We have to reduce it, so that means we can divide the top and the bottom by 4, and it gives you 3 over 2. And the last section, adding and subtracting. Okay, so you can add and subtract as long as they have the same number here. So square root of 2, square root of 2. I'm going to kind of skip the top part just real quick. So it's kind of like you're adding x's. So this is kind of like saying 3x plus 2x. Okay, well 3x plus 2x gives you 5x, right? So if you have 3 of these and 2 of these, it's going to give you 5 of those things. Those things happen to be square root of 2's. Okay, so for example here, if I look, my square roots are the same, square root of 7, square root of 7. So all we got to do is look at the coefficients. Well, 12 minus 4, 12 minus 4 gives us 8. So that means I have 8 of those things. Okay, those things happen to be square root of 7. Okay, now this one we do not have a common square root, so we are going to have to simplify it. So 75, we're going to see which one of our perfect squares multiplies to give us 75. Okay, if you don't remember your perfect squares, they're 1, 4, 9, 16, 25. Well, 25 times 3, I know gives me 75. Okay, minus 27. 27 is the same thing as 9 times 3. Now we can take the square root of 25 and get a whole number. That gives us 5. We can't take the square root of 3 and get a whole number, so that stays trapped in the square root. Minus. We can take the square root of 9 and get a whole number. That gives us 3. And then this 3 here is going to stay trapped inside the square root. Okay. So now I have 5 of these, and I'm taking away 3 of these. So when we look at the first part, 5 minus 3 gives me 2. So we have 2 of those things. These things happen to be the square root of 3. And that's it. And the last one. So we have 6 and the square root of 5 plus the square root of 45. So I'm going to go ahead and break down the square root of 45. That gives me 9 times 5. Now we can take the square root of 9 and get a whole number. That gives me 3. We can't take the square root of 5 and get a whole number, so it stays trapped inside the square root. Okay. Now we have a common square root, square root of 5, square root of 5. So then we just have to look at the coefficients. Well, 6 plus 3 gives me 9, so that means I have 9 square root of 5's. And that's it. Thank you guys. We'll see you next time. Bye.